To date, there's been essentially a progression of herbicide resistance. Initially, it was one herbicide resistant to a single site of action type chemistry, and generally it was due to some genetic mutation in the plant so that the herbicide didn't bind to that specific enzyme that is represented by that site of action. But then over time, as we kept using some of these herbicides, especially the site of action 2, the ALS, and the site of action 9, the glyphosate, you started to see different weeds resistant to the same site of action. Now, one of the issues that's developing with glyphosate resistance is different weeds tend to have some different mechanisms of resistance. So, for example, what we see with the glyphosate-resistant giant ragweed, common ragweed, is going back to that mode of action process, failure to translocate to all the growing points. Okay, so it's just not getting around through the whole plant, and therefore it's becoming resistant to formerly lethal doses. With the water hemp species, we have a different mechanism of resistance. Normally, shikimate 3-phosphate, S-3-P, binds to site of action number 9, EPSP synthase, allowing phosphoenolpyruvate, PEP, to bind to S-3-P. This allows the process of creating aromatic amino acids essential for plant growth. Normally, when glyphosate is sprayed, it outcompetes PEP, stopping the creation of aromatic amino acids and eventually leading to plant death. In glyphosate-resistant water hemp, what we have is the creation of multiple genes encoding for multiple copies of the EPSP synthase enzyme. Therefore, there are more copies of the enzyme than glyphosate molecules, so the normal process of PEP-EPSP binding can continue and the plant survives. And so there's two completely different mechanisms resulting, however, in your field in the same result, failure to control the specific weed. But then sometimes what we do is we switch out, alter to a different chemistry, and we develop what we call multiple resistance, the resistance to several sites of action in the same weed biotype. So if you go back and look at the various herbicide tools you have in corn, soybeans, you start to see that you're starting to lose a lot of options if you have multiple resistant weeds. One of the key things in developing a robust herbicide resistance management plan is to get the right site of action on the right weed at the right time. And one of the issues here is not any one individual site of action has the same efficacy or effectiveness across the spectrum of weeds. So you really need, if you're going to diversify your sites of action, you have to look at it, which herbicide, its specific site of action, and what's its level of effectiveness on a given weed. So if you target a resistant weed, you need to diversify with different sites of action that have equal effectiveness on that weed in order to develop a robust resistance management plan. There's a couple of things you need to understand as you're addressing herbicide-resistant weeds. One is there will be, not even in the near, but in the midterm future, no new herbicide sites of action. Manufacturers keep searching, but those sort of silver bullets really don't exist. What you will be seeing in the near future is taking formerly susceptible crops, inserting resistant traits into them so that you can expand the sites of action available into other crops. But keep in mind the idea we still have to diversify our sites of action across rotations. So we're really not developing any new chemistry, we're just repurposing old chemistry into a different crop. So it doesn't change the issue. It's not the next silver bullet. So keep that in mind, that this is a problem we need to address, and the sooner we address it, the easier it is to deal with.